So I'm uploading this video because we're all going to be on a little bit of a weird schedule with some people taking STAR on Tuesday, some taking it on Thursday. We're going to be displaced both days. So over the next 3 days, I'm going to have you guys hop on It's Learning and watch this video on net ionic equations, which on It's Learning I abbreviate NIE, net ionic equations. And then do some practice problems from the packet. Those will be assigned on It's Learning. Normally, I would just film myself taking notes that I would upload to It's Learning. But this PowerPoint, someone put a lot of time in it and it is amazing. Like the visuals that they did are so good. So I'm just going to use the PowerPoint. You can take notes as you normally would. You guys know by this point kind of how we set up our notebooks. Put your title, net ionic equations for this section, put a little square around it if you want to, and then just jot down anything important from each slide. And I strongly encourage you to draw the particle diagrams that you are seeing. You don't have to draw every little detail because it shows a lot of movement, but the particle diagrams are what is vital that you understand from this, because you already actually understand quite a lot of the foundation for these, but the particle diagrams are what are new. So net ionic equations is exactly what the name implies. It's the net equation, so what happens in the end after you take out everything that doesn't change when you put some ions in solution. So you'll recognize this as a double replacement reaction. Two aqueous solutions were mixed, and it looks like one formed a precipitate. So we learned in Unit 7, I'm so sorry. You learned in Unit 7 that if you have a solid form as one of your products, that's your precipitate. It is insoluble, and you can check on this chart, which is linked straight to It's Learning at the top under reference charts. You can decide who is solid and who is aqueous based on that chart. If both are aqueous, you have no reaction, no visible reaction, and I'll show you why in a second. But this is your precipitate, the silver chloride. So what happens when you put silver nitrate and sodium chloride in water? So here's silver nitrate, here's sodium chloride. Those are both aqueous solutions. They both dissolve in water, and they split up into ions. Okay, remember that's what we call electrolytes, ionic compounds that split up into ions, and they can conduct that electrical current because of those charges. Okay, so you have these reactants floating around, and then silver and chlorine actually, when they get together in the new product, the ionic compound, this is an insoluble product. Okay, so silver chloride now settles out at the bottom of your beaker, and that's what we call your precipitate. A precipitate is simply a solid product that seemingly forms out of nowhere when you react to aqueous solutions. So there's your precipitate. It's insoluble. It's a solid. Okay, the sodium and the nitrate together make a soluble compound, sodium nitrate. Okay, so they're not going to form a precipitate and settle out. They are going to stay dissolved as ions. Okay, you can see them just floating around. Now let's look at it on a larger level. That was just 1 mole of each, or 1 particle of each, or 1 formula unit of each. Okay, so when you dump all of those reactants in, the sodium chloride and the silver nitrate, it just happens on a larger scale in the mole ratio that you would see after you balance the chemical reaction. Okay, so you can see the silver chloride starting to form that insoluble precipitate, and it starts accumulating down at the bottom, or as specks or clouds, however that precipitate shows up. Okay, once all of the silver chloride has reacted and formed all of the precipitate that it can, all you have left are these sodiums and nitrate ions, right? And they're not going to form a precipitate. They stay dissolved in solution because they are soluble. Okay, so these don't really change anything. So to write the ionic equation, you split everything that is aqueous up into ions, right? Because if it's an ionic compound dissolved in water, we know that it splits up into ions. We've already learned about electrolytes. Okay, so you'll have your silver plus, your nitrate negative, your sodium plus, and your chlorine negative, and that's what you saw here before that silver chloride all accumulated at the bottom. Okay, everything split up, sodiums and nitrates, silvers and chlorine. There we go, moving forward. And then for your products, if it's aqueous, it remains split up. Okay, the nitrate and the sodium, but the silver chloride product came together as a solid precipitate that does not dissolve in water. So you draw this as your compound. Okay. One thing that I want to point out, and I did this in a warm-up last week to kind of prep us for this, but you don't have to split up your polyatomic ion into further atoms. You can keep the NO3s together. You don't have to do nitrogens and oxygens. Okay? Okay, so we're going to look at it again. There's your silver chloride. This is your reaction, the silver chloride. Because you see that happening, you see it forming a new compound. These are no reaction because they don't actually get together and form a new compound. They're just floating around as ions. These ions do not participate in the reaction. They're just floating around, so we call them spectator ions. They're just sitting in the crowd watching. Okay? They're watching the silver chloride do all of this work. Boom, you do have a product form. These are involved. These are not spectator ions, your silver chloride. So the net ionic equation is constructed from the ionic equation that we already wrote, but you slash out all spectator ions, okay, because they didn't participate in a reaction. So they're not actually a part of this. Okay, so the silver, the chlorine, and the silver chloride are your net ionic equation. Okay, the nitrate doesn't change. He doesn't do anything. He just sits back and watches. The sodium, nothing happens to him. He just sits back and watches. So we cross those out. If they are not involved in your precipitate in the products, then they are spectator ions. Okay, so your net ionic equation is written without the spectator ions. Maybe. There we go. Okay, so it's just the silver and the chlorine. You keep them as ions because alone they are just floating around in water. But when they form the product, they form silver chloride. So this is your net ionic equation, the thing that actually changed. So practice, and I believe after this slide, kind of everything just repeats. So strontium bromide reacts with potassium sulfate. So you're going to write the balanced formula equation, write the overall net ionic equation. Okay, so you are going to be, before you write the ionic equation, make sure you know which ones are aqueous, which ones are going to split up into ions, and which ones are solid, which ones will come together as a precipitate. When you write the ionic equation, you're going to split up all of your aqueous ones into ions, and you're going to keep your precipitate as a solid, so that's your overall ionic. And then the net ionic equation, you're taking out any spectator ion. Anything that did not come together and participate in that precipitate, two very similar words, then it's a spectator ion, and you do not write it in your net ionic equation. Okay. So again, I'm pretty sure all the rest of this is just on repeat. I am going to assign you some problems to try on It's Learning, and I want you to sketch the particle diagram for each. Okay, and then that's it. That's all we're doing for the next 3 days. This is 2 days worth of work in 3 days because some of us are testing a star on different days. Okay, let me know if you have questions. Be lunch tutorials for me. Come see me.